Okay, we're going to do a limiting reactant theoretical yield problem. All right, so number 4, the first thing it says do is write a balanced equation. So first we just have to write the equation. So nitrogen, which is a diatomic element, is N2, because it's diatomic, plus magnesium, which is just Mg and not diatomic, so we're not going to put a 2. And that produces magnesium nitride. So that is an ionic compound. So we have to do the charges. So Mg is +2. Nitrogen is minus, oh, I didn't give myself enough room there. That's okay. Nitrogen is -3. So to balance out those charges, we have to have a formula of Mg3N2. Okay, so that's our formula. That's our equation. Now we have to balance it. N both has 2, so N's good. Mg has 3 on this side and 1 on this side, so we need a 3 in front of the Mg. And there we go. We have a balanced equation. Okay, so now, what is the theoretical yield when 5 grams of magnesium is reacted with 25 grams of nitrogen gas? So basically what we have to do here is 2 stoichiometry problems. One with the 5 grams of magnesium and one with the 25 grams of nitrogen gas. Doesn't really matter which one you start with, so I'm just going to pick 5 grams of magnesium since that's listed first. So we have 5.00 for sig figs grams Mg. Okay. Now, we want to convert this into grams of the product. Now, this one just has one product, so obviously we're going to convert it to that. If it has 2 products, then you look at the problem, okay? If it says which product to convert to that one. If it doesn't say, then you can just pick one. It doesn't really matter which one you do, okay? All right. So we put that over 1. We do our first conversion factor. We want to cancel out grams of magnesium, so we put grams Mg on bottom. We put moles Mg on top, 1 mole, and then we put the molar mass of magnesium, which is 24.31. Okay, grams of magnesium cancels out. We're left with moles of magnesium, which is not where we want to be. So we need another conversion factor. Moles of magnesium goes on bottom to cancel out magnesium, or moles of magnesium. And then we need moles of our product on top. So moles Mg3N2. Now, this is a mole-to-mole ratio. So we need to get our coefficients for each of these different reactants and products. So the coefficient for Mg is 3. Whoop, that's not the right place. Sorry. 3, because that's Mg. The coefficient for Mgn2 is 1. So we put a 1 there. Okay, moles of Mg cancels out. We're left with moles of Mg3N2, which is not where we want to be. So we need we need another conversion factor. So we need moles Mg3N2 on bottom to cancel out, and we need grams Mg3N2 on top. Okay, we're going to put 1 in front of moles. For in front of grams, we put the molar mass of Mgn2, which turns out to be 100.95. Okay, so then we cancel out moles of Mgn3. We're left with grams of Mg3N2, which is where we want to be, so we don't need any more conversion factors. Okay, so now we do our math. We multiply all the top numbers. 5 times 1 times 1 times 100.95. We get 504.75. We do all our bottom numbers. 1 times 24.31 times 3 times 1, and we get 72.93. We divide those, and we get 6.92. 2 grams of MgN2. I'm sorry, Mg3M2. Okay, so that's our first stoichiometry problem. Now we have to do another one, the 25 grams of nitrogen gas. So we start with 25 grams N2. I'm going to try to write a little bit smaller this time because I'm going to run out of room here. Okay. So now, again, we're converting to the same product. That's another thing if you have multiple products. It doesn't matter which one you pick, but you have to do the same one for both of your stoichiometry problems. Okay? So we do our conversion factor. Grams N2 goes on bottom. Moles N2 goes on top, 1 in front of moles. The molar mass of N2 in front of grams, which turns out to be 28.02. Grams of N2 cancels out. We're left with moles of N2. That is not where we want to be, so we need another conversion factor. Moles N2 on bottom, and we are converting to moles of Mg3 and 2 on top. So now again, this is our mole-mole ratio. So we're looking for our coefficients. So moles of N2, that's 1. Moles of Mg3N2, that's also 1. So moles of N2 cancels out. We're left with moles of Mg3N2, which is not where we want to be. So we need another conversion factor. Moles Mg3N2 goes on bottom. Grams Mg3N2 goes on top. 1 mole on bottom. 100.95 on top. Moles MgN3, or moles of that cancel out. We're left with grams of that, which is where we want to be, so no more conversion factors. Now again, we do our math, so 25 times 1 times 1 times 100.95, and we get, I don't know if I'm going to have enough room for this, 2523.75 on top. And then we do our bottom math, which is a whole bunch of ones except for 28.02. So now we take our 2523.75 divided by 28.02, and we get 90.07 grams Mg3 and 2. Sorry about the lack of space there. Okay, now, we're still not quite done. We're done with all our math, but now we have to identify all of our stuff. Okay, now, for the theoretical yield, okay, this is asking for the theoretical yield. Okay, now, for the theoretical yield, these are our two answers. Okay, this is the maximum that each one of our givens can produce, okay, if we have unlimited of the other given. So what that means is whichever one of these is lower is the theoretical yield, okay? So that means not the 90.07, okay? It's going to be the 6.92. That is our theoretical yield, not our limiting reactant, okay? If this particular one doesn't ask for limiting reactant, but if it did, then whichever one of your two givens, so the 5.00 or the 25.0, I forgot to do 0.0 over here, whichever one of those produced the theoretical yield, that is your limiting reactant. So since 5 grams of magnesium produced the 6.92 grams of magnesium nitride, the 5 grams of magnesium is your limiting reactant. Okay? Okay. That is it for that.